Who's ready for applications of the unit circle? Whoops. There we go. Section D is split up into two different parts. So the notes are pretty short. They could easily be one day, but we decided to split them up to really give you some time to, focus on each different part. So we're going to talk about applications of the unit circle today. Probably a good idea to have your unit circle out. Way to go, Joe. Yeah. Just give me a minute. Don't forget your unit circle. Or not your unit circle, I mean your stat box. Do you need it? Okay. I can't even get it together. Alright, so we talked about this identity on Friday. Cosine squared plus sine squared equals 1. It is in your formula packet, so that's good news that is in your formula packet. It is on the same page as the arc length and sector area, so that's pretty nice that it's right there for you. One thing to note is that I know this says like the squared is in here, and I really couldn't tell you who made that decision, but what this really means is it's the value of the cosine. So whatever the cosine of the angle equals, you square it. And whatever the sine of the angle equals, you square it. So if it helps you to rewrite it so that you kind of know that, that's up to you. But so let's say that the value of cosine is, let me pick something off of here. Let's see, 1/2. Then you'd have to square the 1/2. Or if the value of sine is square root of 3/2, you have to square root of 3/2. Like whatever it is, you have to square that. We will be pushing you to try to work with this stuff without a calculator, so just be open to trying that as we kind of go forward here. So here is our first example. Find the possible exact values of sine of theta if cosine of theta equals 3/4. So we want to find the possible exact values of sine of theta if we know the cosine of theta equals 3/4. I know it doesn't say no calculator, but like I said, let's just try to push ourselves to try not to use the calculator on this one. And so I can use that identity, cosine squared plus sine squared equals 1. And I'll go ahead and I'll put 3/4 in for cosine. So I've got 3/4 squared, because remember how we talked about what that really means, plus sine squared theta equals 1. I think it's really important we can understand how that substitution works, especially with that squared like we've been talking about. Are there any questions about that? So now I go ahead and square it. And don't freak out, you just square the numerator and the denominator. So 3 squared is 9 and 4 squared is 16. So I have 9/16 plus sine squared theta equals 1. I'm working on figuring out what sine is. So what do you guys think we should do next? Yeah. we can subtract the 9/16. So now these will cancel out. And again, if we want to try to push ourselves to subtract without using a calculator, 1 would become 16/16 minus the 9/16. Remember, when we subtract fractions, we subtract the numerators as long as they have common denominators. So what's 16 minus 9? 7. So I end up with sine squared equals 7/16. Okay? So it's sine squared equals 7/16. So how do you undo squaring? Square rooting. Now, do you guys remember when you square root how it could be positive or negative and you have to have the positive or negative values? So I end up with sine of theta equals plus or minus. Now, what's the square root of 7? Yeah, we can't simplify that, so we'll leave that square root of 7. But what's the square root of 16? And so this plus or minus here is why it says exact possible values. Because remember we talked about how those values sort of repeat themselves on this unit circle. And we don't know if it's going to be a positive or a negative. Like, there's no information in this problem that tells us if it's going to be in, let me see here, if it's going to be in quadrant 1 or if it's going to be in quadrant 4. Like, we don't know. So we have to put both of those values down. And remember, exact means that we're not using those decimals, right? I didn't plug this in on my calculator and approximate a value. So we have no decimals because we got the exact. Any questions about any of that? So on this one, we don't know if it's positive or negative, but sometimes we do have problems that give us some more information, and then we can determine if it's positive or negative, which we will see on our next example. So this one says, I'm going to zoom it in. It does say without using a calculator, find that. So I'm going to zoom it in to just this problem and just tell you. It says without using a calculator, find. And now we can actually see it, right? So if you missed the words, they were without using a calculator, find. So you want to find tangent exactly if the sine of x equals negative 1/4 and if x is in between pi and 3 pi over 2. So let's think about this. So tangent wasn't a part of that formula we had been using, cosine squared plus sine squared equals 1. But what did we remember about tangent on Friday? Absolutely, that tangent equals sine over cosine. So that is also in your packet. So if you don't remember that, you can check your packet, or if you're like me and you're like have these doubts of like, is it sine on top or is it cosine on top? Like if you have a doubt, just check your packet. So we already have sine, so we're gonna have to find cosine in order to find tangent. So does that make sense so far? We have to find the cosine. Once we have the cosine, we can put sine and cosine into this formula to find tangent. So the other piece of this then is this pi to 3 pi over 2. For that, take a look at your unit circle. What quadrant is this? from pi to 3 pi over 2. I'm not asking you to memorize it. I'm asking you to look at your unit circle. Is it quadrant 1, 2, 3, or 4? Good, it's quadrant 3. So we're looking at quadrant 3. Do you guys see that? So like on the x-axis it says pi, and then on the y-axis if you go down it says 3 pi over 2. Okay, if you don't see that, maybe call me over so I can point that out to you. That will tell us what's going to be positive or negative. So maybe we also remember from Friday, what was it, a smart trig class, where all students take calculus, or a silly turtle crawls, right? So this means that in this quadrant, tangent is positive. That's a big clue. Our final answer should be positive. We also know in this quadrant, cosine is negative, because the only thing that's positive is tangent. So we can use that information to determine if we've got positive or negative values. So that's how it's also a little bit different from the last example. Are we ready? Because we can start by finding that cosine. So I'm just going to write the formula down again, and we can use that. So I'm going to put sine in here. So I've got cosine squared x plus negative 1/4 squared equals 1. So I'm taking the same approach as the last problem. I know I had cosine, I had to find sine, but it really works the same way. When you have sine, you have to find cosine. We're supposed to push ourselves to do this without a calculator. So what's negative 1 squared? Hopefully you all said 1 in your heads. And then what's 4 squared? 16. Then we can subtract that 1/16. I know that's like the scariest part in our heads, right? Remember that 1 can be 16/16. So I end up with cosine squared x equals 15/16. Am I doing that subtraction too fast or anything? I just know what fractions can kind of weird. So then I can square root. So cosine of x equals the square root of 15. What's the square root of 16? So over 4. Except since I know that I'm in this quadrant 3, my cosine will be negative. So I have negative square root of 15 over 4. It's not my final answer, but that's just definitely a part of the problem that I need. So again, we decided it was negative based on the fact that we know it's in that quadrant. And if you forget a silly turtle crawls, I mean, if you look at this, you can see, oh yeah, all of those x values are negative, so cosine is negative. So even just looking at your unit circle can help you with that. Then we can come over here and we can plug in these values. So in the numerator is sine, which was negative 1/4. In the denominator is cosine, which is negative square root of 15 over 4. So hopefully you notice that those double negatives will become positive. And we can, instead of, especially because we're not supposed to use our calculators, hopefully you remember that dividing by a fraction is the same as multiplying by a reciprocal. So my first fraction stays the same, but I flip around the second one. If you left the negatives, you would see here that they would go positive. Those 4's cancel out, so I have 1 over the square root of 15. And it does make sense, like we said, we know tangent will be positive in that quadrant. Sure enough, our answer is positive. Now I know in Algebra 1 and in Geometry and in Algebra 2 or Trig, it was like drilled into your heads, no radicals in the denominator. And then you get to this IB class, and IB's kind of like, it's fine, no worries. So I believe if you check in the back of the book, it would stay like that. If you wanted to rationalize, you'd end up with the square root of 15 over 15, but it should be fine to just leave it like that. Any concerns right now with this material? Okay. So your stat box is, why is the unit circle important? We didn't look at our unit circle for like finding an answer like we kind of talked about on Friday, but why is it important? What did it help us figure out on that second problem? Yeah, the signs. It's important because it helps you figure out if it's positive or negative, depending on whatever trig function you're looking at. So that's why that's important. And then here is your, this is D part 1.